All right, so we are looking at operations with polynomials. We're going to multiply, divide, and simplify over the next course of this unit. And today we're going to just start with simplifying and classifying. So as part of the warm-up, it said to find the x-coordinate of the vertex. So you had f of x equals 5x squared plus 15x plus 1. So the x-coordinate of the vertex was kind of like our h value, which was also equal to negative b divided by 2a, which in this case was negative 15 divided by 10, which reduced to dividing both by 5. So you got negative 3 over 2. And then it says write a quadratic equation with roots negative 3 and 3/4. So that's like saying x equals negative 3. So that becomes x plus 3. X equals negative 3 or positive 3/4. So you multiply both sides by 4 and subtract your 3. So in factored form, that's x plus 3 or x minus 3. And then to get to standard form, you FOILed that. So x times 4x was 4x squared. X times negative 3 was negative 3x. 3 times 4 was positive 12x. And 3 times 3 was negative 9. So that reduced or simplified to 4x squared plus 9x minus 9. So again, that's standard form, which is ax squared plus bx plus c. And then it said find the exact solutions. So the solutions are what you get when you factor or quadratic formula. So you could have looked to factor this. So you would have maybe possibly taken out a negative 1. Leaving you x squared minus 8x plus 12 equals 0, which meant that you needed factors of a positive 12 that added to negative 8. So two numbers that multiply to positive 12 and add to negative 8 are negative 6 and negative 2, which meant this factored as x minus 6, x minus 2. Which meant your roots were positive 6 and positive 2. So that's just a review of where we were. Now where we're going to polynomials. So quadratics are a type of polynomial with degree 2. Polynomials are anything that is a degree greater than 1. So the degree of a polynomial is the degree of the monomial with the greatest degree. So I have two examples up there for you. These are both considered polynomials because they have plus and minuses. A monomial is the singular term, so 4x squared is a monomial, 3x cubed is a monomial, 5x to the 5th is a monomial. A polynomial is the summing of monomials together. The degree is only the degree of the highest powered term, so it doesn't matter that there's a square or a cubed function, its degree comes from the 5. If you have two variables being multiplied together, then we add their degrees together to get the degree of that term. So x and y are both degree 1, making that term a degree 2. So you don't need to write down the examples unless you think you need them. You can stick to just the definition for this part. And we're going to zoom in so that you can see those definitions. So again, I put the example column, but if you don't need that, we're going to do plenty of examples as a group. So a product of powers says that if you multiply two like bases together, you add their exponents together. So if you have two like bases and they're multiplied together, you add their exponents. The quotients of powers says that if you have two like bases and you're dividing them, then you subtract their powers. If you have two like bases and you're dividing them, then you subtract their powers. Any variable to a negative exponent can be rewritten as 1 over that variable with a positive exponent. If you have a power of a power, then you multiply. So x to the a raised to the b is really like x to the a times b. If you have two things being multiplied in a power on the outside, that power distributes in to both parts. That distribution holds true for a power to a quotient. And anything to the 0 power is always 1. Anything to the 0 power is always 1. Okay, anybody still copying any of that down? Okay. So there are a few steps we're going to take in order to simplify a monomial. Those steps are going to be removing all powers of powers, combining all like terms, ensuring fractions are in simplest form, and leaving no negative exponents. So, for example, we have a to the negative 3, a squared, b to the 4th, c to the negative 1. So we're going to combine all like terms. So in this case, the a's are like terms. So if you have two like bases and they're being multiplied together, then the rule of sum is that you add their exponents. So that's like a to the negative 3 plus 2. B to the 4, and c has a negative exponent. So if it is a negative exponent, you drop it to the denominator as a positive. So that gives a to the negative 1, b to the 4th, all over c. But once again, we cannot have a to a negative exponent, so we drop that down. And our final answer is b to the 4th all over ac. And again, there are a few ways you could have gone to that. Maybe you took your steps a little differently, but you need your final answer to be b to the 4th all over ac. Okay, if you have division of like bases, then you are going to take the top minus the bottom. So you get 2 minus 10. So 2 minus 10 is negative 8. But again, we can't leave our answer with a negative exponent, so we rewrite it as 1 over n to the 8th. If you have a fraction and they're being divided and then all raised to a power outside, that outside power distributes to all parts inside. So that's 6 squared, r squared, squared, which is like squared times 2, 3 squared times s cubed, also multiplied by 2. So then we simplify our numbers and variables. So you get 36 r to the 4th, because 2 times 2. 3 squared is 9. And 3 times 2 is 6. Now, you can simplify your numbers, and you could have simplified your numbers here and said 6 divided by 3 was 2, and 2 squared was 4. If you did what we did on here, then you would now say, okay, 36 divided by 9 is 4. And that 4 goes in the numerator. So you have 4r to the 4th all over s to the 6th. So again, when you simplify the fractions and the numbers, we're going to simplify them at the beginning or the end. It doesn't change your answer. Okay, and then the last thing we want to do is determine the degree of a polynomial. As I said before, the degree depends upon the terms of the polynomial. So in this case, this is not a polynomial because we have a square root. A square root is not considered a polynomial. Therefore, this has no degree because it is not a polynomial. So again, a square root is considered to a 1/2 power. A fractional power is not considered a polynomial. Polynomials have to have whole number exponents. Okay, example number 2. This is a polynomial. We have p cubed plus 3/4 p squared q7. The degree is 9 because we add the degrees of the exponents of the monomial. Okay, and then again, the last one is not a polynomial for the same reasons. When we had division by x, that's not linear. Linear, again, is a type of polynomial. We know that in order to be a polynomial, you cannot divide by x. So the minute that that had an x to the -1, that made it a non-polynomial. Okay, and the last thing we're going to do is simplify polynomials with addition and subtraction. So the key idea here is that if you have a negative in front of your parentheses, that negative distributes to every part within those parentheses. So this is 2a cubed plus 5a minus 7. That negative distributes in, so it's negative a cubed. A negative times a negative gives a positive 3a and a negative 2. When simplifying with addition and subtraction, you look for like powers. So that first term and this term both have a cubed. So a cubed are like terms. So 2a cubed minus a cubed is 1a cubed. 5a and 3a gives 8a. So again, you're only adding the coefficients. You're not changing their powers. And negative 7 and negative 2 gives negative 9. If you have a plus sign between them, then no signs within the parentheses change, and everything is as it is. So we're just going to combine like terms. So 4x squared and negative 2x squared is 2x squared. Negative 9x and negative 5x gives negative 14x. And a positive 3 and a negative 6 gives a negative 3. If there's a negative, then we have to distribute, so we rewrite it, then combine. So you have 3x squared plus 2x minus 3. Some people, when they rewrite and combine, like to stack the like terms, so that's an alternative. So I could write that as minus 4x squared minus x plus 5. Where you stack the like terms and you add them downwards now. So 3x squared minus 4x squared is negative x squared. 2x minus x is x. And negative 3 plus 5 is positive 2. So again, you can continue to write horizontally. You can stack them vertically. Both ways get you to that same final answer. Okay, and then once again, you have negative 3x squared, negative 4x, positive 1, negative 4x squared, negative x, positive 5. Combining like terms, you get negative 7x squared, negative 5x, and positive 6. So your homework is the next two handouts in there. You're doing the polynomial practice page, and then you're doing the adding and subtracting. So you're doing the polynomial practice and the adding and subtracting. Tomorrow we'll look at operations with polynomials day 2. And then at this time, I'm going to call you guys back just alphabetically to sign, or I'll walk around maybe just alphabetically to sign all of your handouts for next year's classes.